Hi guys, so good morning. For today, we will be discussing chapter 5, the states of matter. The states of matter, we have three states of matter that I know you have already discussed in your previous chemistry subjects. This states of matter is solid, gas, and liquids. And aside from states of matter, we will also discuss the law, uh, like Charles ideal gas law, combined gas law. We will discuss everything later. So let's start with gas. Gas pressure. Pressure is a force per unit area exerted against a surface. So, most commonly measured in milliliters of mercury, atmosphere, or torr. So, meron tayong iba't ibang measurement of uh, we have different types of measurement for pressure, no? And ang most common natin na ginagamit, yung standard natin na pressure is 1 atmospheric pressure and equivalent yun sa 760 mercury millimeter or 760 torr, no? Pwede rin siyang 101,325 Pascal, 29.92 inches of mercury. Pwede rin siyang 1.01325 bars. Pero among the following units of measurement, the most commonly used, no, in solving formulas that we will be discussed later is the 1 ATM and 700 and mercury millimeter. Now, sometimes you also use torr, but 1 ATM is the most commonly used. While in practical usage, no, ang kadalasan natin ginagamit is yung mercury millimeter. Say for example, sa mga sphygmomanometer, have you handled sphygmomanometer? Yung pang BP, no? Sphygmomanometer po ang tawag doon. At ang ginagamit natin itong pang-measure na unit is the mmHg. So, atmospheric pressure is measured using our barometer. No, kapag naman pressure of a confined gas, specific siya for a confined gas, gaya nung ating sphygmomanometer na ginagamit na pag-measure ng BP, no? Manometer po ang ginagamit natin. Kapag sa atmosphere, so yung ginagamit sa pag-asa, no? Gumagamit tayo ng barometer. Barometer ang tawag. Yun yung pinagkaiba. This one is a mercuric barometer. Okay, so we have three types of gas laws that will be discussed, and yung further laws or further computations are just combination of these three laws. So meron tayong Boyle's law, Charles law, and the third one is the Gay-Lussac's law. So for Boyle's law, no, ang sinasabi dito for a fixed, always remember guys dito sa pag memorize ng mga law. Minsan kasi hindi siya lumalabas sa exam as computation or as problem solving. Tandaan niyo kung sino yung fix ang amount sa kanila at sino yung nagbabago-bago. So for this one, Boyle's law, no? Before that, may papatandaan na ako sa inyong mnemonics para hindi kayo mahirapang mag-memorize, no, ng ating mga gas law, no? So P, V, and then T. No? So this one is Boyle's. This one is Charles. Ito yung Gay-Lussac. So para matandaan ko siya kung ano yung formula na yon, no? BGC. Tapos yung Boyle's law natin, palit ang color ng pen. Yung Boyle's law natin is P1, P1V1, P2V2. Ito yon, P1V1, P2V2. Yung Gay-Lussac's law natin is P1 over T1 is equal to P2 over T2. Ito yung Gay-Lussac's. And yung Charles law natin, sorry, mnemonics lang to guys. Syempre, i-discuss pa rin natin. Yung Charles law natin is V1 over T1. V1 over T1 is equal to V2 over T2. Ito yon, yung Charles law. Naintindihan ba yung mnemonics ko? So, BGC. So, may isa pa ako para mabilis tandaan. Sorry. That yung pala inuna ko, ano. So, BGC, tandaan nyo yun, ha? PVT. Tapos, BGC. And, guys, kapag Kapag, halimbawa sa Boyle's Law, no, ang meron tayo dyan, di ba, is P1 times V1. So, tatakpan nyo tong T. No? Takpan nyo ng kamay nyo, ng daliri nyo yung T. Ibig sabihin, kung ano yung tinatakpan ninyo, kung ano yung tinatakpan ninyo, yun yung constant. Naiintindihan? Kung alin yung hindi kasama doon sa, alin yung hindi kasama doon sa formula, yun yung constant. Naiintindihan ba? So, halimbawa naman sa Gay-Lussac's law, P1 over T1, ano yung constant dyan? Yung volume. Naintindihan? Try nyo takpan yung volume. Matitira na lang is yung P at saka T. So, P over T yun. Naiintindihan ba kung paano ginagawa yung mnemonics? So, isa-isahin natin na sa Boyle's law daw, for a fixed mass, tandaan nyo, fix yung mass of gas. Tandaan nyo, itong laws, tatlong law na to pala, ay effective, no, at accurate for ideal gas. Though walang nag-i-exist na totoong ideal gas, yung mga gases natin ay malapit ang value na kukuha compare kapag i-apply natin yung law tsaka yung kinetic molecular law sa ideal gas. Okay, so itong Boyle's law for a fixed mass of gas at a constant temperature, takpan nyo yung letter T, takpan nyo nga ng daliri nyo. At a constant temperature, the volume is inversely proportional to pressure. So, volume is inversely proportional to pressure. Paano nag-arrive dun sa formula? Di ba pag ganito, pwede nating i-multiply to dito. So, parang ang mangyayari dyan is P times V is equal to 1. So, kasi constant, no? Constant yung 1. And kapag nadodouble, may initial at may final tayo na value, pwede natin i-apply yung P1 times V1 is equal to P2 times V2. Naiintindihan yun. Next is our Charles law. So, sa Charles law naman, for a fixed volume of gas at a constant pressure, no? So, yung mnemonics natin, PTV. At a constant pressure, so takpan natin yung pressure, ano yung matitira? V at T. Volume is directly proportional to temperature in Kelvin. Always remember, guys, sa gas, ang ginagamit natin in terms of pressure ay ATM, pwede ring mmHg, pwede ring torr. Okay? For temperature, Kelvin ang ating ginagamit. For volume, liter ang ating ginagamit. Okay? So, dito sa Charles law daw, ang ating constant ay pressure. Volume is directly proportional to the temperature in Kelvin. Okay? For Gay-Lussac's law naman, guys, for fixed mass, ano ulit yung mnemonic? Sorry po, ulit-ulit ako. Okay? Sabi dito, pressure is directly proportional to temperature. Ano daw yung constant dito? Para lang hindi makalimutan, lagi kayo mag-drawing itong triangle ko na to. Baliktad yung triangle, no? Constant daw ang volume. So, anong matitira? P and T. Tama ba, B? GC. Okay? So, ito yung summary natin. Pero again, guys, para hindi na kayo mag-isip-isip pa, mabilis mag-solve, tandaan nyo lang tong triangle ko. Sana matandaan nyo, no, itong triangle. Okay, so, itong Boyle, Charles, and Gay-Lussac, guys, sabi ko kanina, pag pinagsama-sama, nagkakaroon tayo ng tinatawag na combined gas law. So, actually, ito rin yung triangle ko kanina, no? Itong formula na ito, P1, V1 over P1. So, sa problem, usually, itong formula na to yung ginagamit natin. Okay, and kapag sinasabi lang halimbawa, sinasabi na constant naman daw yung temperature, minsan ini-eliminate na lang natin yung constant. Halimbawa, sinabi na given yung partial pressure, given yung volume, given yung final na pressure, given yung final na volume. Pero ang sabi doon, constant daw yung temperature, ino-omit na natin yung temperature. Ito na lang yung isasama natin sa problem. So, kung ano yung constant, minsan hindi na siya ini-include. Okay? Kasi guys, kung iisipin ninyo, no? Kung yung T1 na yan ay constant, say for example 1, ito ay 1 din, no? Kung ano yung makuha yung value dyan, parang wala ka rin divide sa 1. Kung yung volume yung 1, ganun din. Okay? Next tayo. So, a gas occupies 3 liters at 2.0 atm. Calculate its volume when the pressure is 10.15 atm at the same temperature. Gaya nito. Same daw ang temperature. So, instead of using P1, V1, P2, V2 over temperature, kahit i-omit nyo na yung temperature, ito lang yung gamitin nyo na formula. Ma'am, bakit yan lang? Ano ba hinahanap? Calculate its volume when the pressure is 10.15. So, ang hinahanap dyan is yung final volume. Okay? Kasi given yung initial volume, initial pressure, no? Given din yung final pressure, ang hindi given is yung volume. Substitute na lang lahat ng value. Again, guys, kung sino yung sinasabi niya na kung sino yung sinasabi niya na constant, hindi na natin nilalagay yan sa formula. Okay? Next is Avogadro's law. Okay, so naaralan natin yung Avogadro's law dun sa chapter 4, tama? Ito yung 6.02 times 10 raised to 23 pala. Natatandaan ba yun? So, sa Avogadro's law, halos ganun din yung sinasabi for Avogadro's law in gas law. So, equal volume of gas at the same temperature and pressure contains the same number of molecule. 'Di ba? Ano yung sinasabi doon sa Avogadro's law? Say for example, guys, yung sulfur. Or sorry. Oxygen. Ang isang atom ng oxygen ay ilan ang bigat? 16 grams. Tama ba ako? 16 grams. Correct me if I'm wrong. 16 grams. Alam natin na constant ang molecule na yan ng 16 grams. Ang 1 mole, no? 1 mole of oxygen is equal to 16 grams. At ang isang mole is equivalent to 6 times 10, 6.02 times 10 raised to 23. Tama ba? At yung 6.02 times 10 raised to 23 is ang bigat niyan is 16 grams. So, yung sinasabi sa Avogadro's Law, guys, bibigyan ko kayo ng reviewer for Avogadro's Law. Pero hindi ako yung gumawa. Again, video din siya na I find it very easy to understand. So, I hope you will understand it too. No? And Avogadro's Law, equal volume of gas at the same temperature and pressure contains the same number of molecule. So, ganun din sa mga gases daw natin. No? So, the actual temperature and pressure at which we compare two or more gas does not matter. For convenience in making comparison, chemists have selected one pressure as a standard pressure and one temperature as a standard temperature. Tandaan ninyo, kapag hindi given ang temperature, hindi given ang pressure, meron tayong tinatawag na STP, standard temperature and pressure. For temperature, it's 273 Kelvin or 0 degrees Celsius. For pressure, it's 1 atm or equivalent to 760 mm Hg. Okay, meron din sa volume yan. 22.1 po sa volume. I don't know kung naisulat. Ay, 22.4, sorry. So, all gases at standard temperature, pressure, any other combination of pressure and temperature contains the same number of molecule in a given volume. But how many molecule is that? So, again, tulad na sinabi sa Avogadro's, 1 mole contains 6.022 times 10 raised to 23 formula units. So, what volume of gas at standard temperature pressure contains this many molecule? Ano daw ang volume? Guys, standard din po, 22.4 liter. Okay, so 1 mole of gas, any gas, ano, ang standard temperature pressure na pwede nating i-apply ay 1 atm, ano pa, 22.4 liter, and 273 Kelvin. Okay? So, yun yung standard natin. Kapag hindi given, yun yung gagamitin. Okay? So, meron din tayong tinatawag na ideal gas law. Again, guys, wala talagang mga ideal gas. No? So, ginamitan lang natin ito ng mga standard values. No? And nakita naman na sa ating mga gases na iba, no, nagko-comply naman sila sa ating rules for ideal gas. So, ang ating ideal gas law is PV, pressure times volume, is equal to N. Ano yung N? Moles of gas. No? Ano yung R? Ideal gas constant, a constant for all gases, and T yung temperature in Kelvin. Okay, so we find the value of R by using the fact that 1.00 mole of any gas at STP occupies 22.4 liter. So, para mahanap natin, i-compute natin ano ang value ng R, i-apply natin dun sa ideal gas law, which is PV is equal to nRT, di ba? So, para mahanap natin yung R, dinerive natin yung formula. Ano? PV over NT is equal to R. So, para mahanap yung R. And by solving, no, kung mapapansin ninyo, 1 atm standard pressure, 22.4 standard liter, 1.0 mole, no, and 273 Kelvin, sorry, yung standard temperature. So, na-compute na ang R natin pala, no? Ang R natin ay 0.0821 liter by atm over mole per Kelvin. So, yun pala yung ating ideal gas constant. Tandaan nyo na, ang ideal gas constant, tandaan nyo rin yung unit, liter per atm over mole per Kelvin. So, 0.0821. So, i-solve natin itong problem, no? 1.00 mole of methane gas occupies 20.0 liter at 1 atm. What is the temperature of the gas in Kelvin? So, apply natin yung ideal gas law. Kasi ang hinahanap, given kasi ang mole, no? Ito yung N, tama? Given ang volume, ito yung V. Given ang pressure, ang tinatanong is yung temperature. Alam na natin ang R. Tama? So, derive na lang tayo. Again, PV is equal to nRT. Kung hinahanap yung temperature, PV over nR is equal to temperature. Tama? So, shortcutin natin ang PV. PV is 1 atm. Volume is 20.0 liters. Over N, ano yung N? Kung ilang mole. So, 1.00 mole. Ano yung R? Yung ating ideal gas constant, which is 0.0821. Anong unit niyan, guys? Liter by atm over mole per Kelvin. Yan yung unit niyan. So, magiging answer should be your Kelvin. Okay? Kasi makakancel atm, liter, mole, matitira ay Kelvin. So, the answer is 244 Kelvin. Okay? Next tayo. Next law natin is Dalton's partial law. Guys, actually, madali lang to, no? Plus lang. So, ang total pressure daw na meron, no? Ang total pressure daw ng mixture of gases, ipagsasum nyo lang, no? I-add lang natin ang lahat ng pressure ng gases na present. Yun yung Dalton's gas. Guys, ito yung sinasabi ko kayo ng Kinetic Molecular Theory of Gases. So, ito actually ay naka-apply sa ideal gas. Pero dahil nga nagko-comply sa ideal gas yung karamihan sa ating mga gas particles, no? Nagko-comply pa din dito yung iba nating gases. So, kaya nating i-assume na nagko-comply pa rin dito yung iba nating gases. So, number 1, gases consist of particles constantly moving through space in random direction and with various speeds. So, alam naman natin na ang ating gases, solid, and liquid ay merong intermolecular force of attraction which will be discussed later, no? And bawat force of attraction noon sa ating gases, ang intermolecular force of attraction ay kaparehas sa solid at gas. Ang kinaibahan lang sa gases, masyadong mataas ang kanilang kinetic energy. na nabe-break nila yung intermolecular force. Kaya yung ating mga particles sa ating mga gas ay nagsushoot kung saan-saan. Kumbaga, gumagalaw sila at high speed, no? Sila ay unstable, no? Ang ating mga gases. At hindi sila nagbabump, hindi sila pag nagbabump sila sa isa't isa, pero hindi sila dumidikit. Kasi nga, mataas ang kanyang kinetic energy, sobrang taas na kayang sirain yung intermolecular force na nagdidikit sa mga molecule like liquid and solid. Okay, so gas particles have no volume. There are no attractive force between gas particles, no? No attractive force kasi binibreak ng kinetic energy. The average kinetic energy of gas particle is proportional to the temperature in Kelvin. So molecular collision are elastic. When molecules collide, they may exchange kinetic energy, but the total kinetic remains constant. So molecules collide with the walls of their container. This collision constitutes the pressure of the gases. Okay, so yung ating ideal gas is the sixth assumption of the KMT gives us an idealized picture of the particle of a gas and their interaction with one another. So yung totoong mga gases natin, their atoms or molecules do occupy some volume. Tama? Tama, oh. Yung oxygen nga, di ba, meron tayong volume. May grams ang oxygen. So, sa ideal gas, no? Sinasabi natin na sa kinetic molecular theory na wala silang volume. Pero ang real gases do have volume. Of course, they have um, electron proton that has weight, no? There are forces of attraction between their atoms and molecules. Merong forces of attraction between their atoms and molecules, no? Pero yung sinasabi kanina is yung intermolecular force of attraction. Tandaan nyo, meron din tayong inter at meron tayong intramolecular. I will discuss that later. So in reality, no gas is ideal, no? At standard temperature pressure, however, most real gas behave in much the same way predicted by the KMT. Okay? So, yung intermolecular forces, this is the strength of attractive force between molecules. So, pare-parehas lang ang ating intermolecular forces sa solid, liquid, and gas. Only that, magkakaiba sila ng level ng kinetic energy. So, at or near standard temperature pressure, the forces of attraction between molecules of most gas are so small that they can be ignored. When temperature decreases or pressure increases or both, the forces of attraction become important to the point that they cause condensation or solidification. So in order to understand the properties of liquids and solid, we must look at the nature of these intermolecular forces. So guys, I don't know kung bakit parehas tong intra. All I know is this should be intermolecular. No, na-discuss natin before yung ionic. When we say ionic, ito yung gain or lose of electron. Tama? So, gaya ng sa sodium chloride, no? Si sodium, yung nagpasa kay chloride ng isang electron para makompleto yung covalent bonding. Okay? Kapag naman yung ionic bonding. Kapag naman covalent, ito yung nag-share lamang sila ng electrons. Okay? How about your intermolecular force? Ito yung sinasabi ko kanina, na lahat ng solid, liquid, and gas, they both have the same level of intermolecular force of attraction. So, pag sinabing intermolecular, between molecules na siya. Kung papansin nyo, yung intramolecular, between atoms. Okay? Molecule times molecule. Halimbawa, same molecule is being attached to the same molecule. So, say for example, H2 is attached to another H2 molecule. No? Methane is attached to another methane molecule. So, meron tayong tatlong klase ng intermolecular force na i-discuss for today. No? For hydrogen bonding, guys, nag-i-exist lagi ito sa ating hydrogen. So, kapag ang nakabind kay hydrogen is an oxygen, fluoride, or isang mataas ang electronegativity na atom, no? And kapag dipole-dipole, guys, nag-exist yan sa positive at negatively charged charged atoms. Like this one, no? Yung ating oxygen is electron rich yan. Electron rich. And yung attraction ng electron rich na yon, ma-attract yan siya sa electron poor no? Na si carbon. So, yun yung dipole-dipole attraction. Tandaan nyo, mga intermolecular forces natin, they are weak bonding sila. Except for hydrogen, no? Strong bond ang hydrogen. Si dipole-dipole and London dispersion is very weak intermolecular forces. Pero ang pinaka-weak sa kanila ay si London dispersion force. Kung makikita nyo, 0.01 to 2.0 ang kanyang typical energy. So si London dispersion forces is present on all living organism, on all types of interaction, on all types of bonding. And itong si London dispersion, very easy siya, very easy to break. Okay? Very easy siya to break. So si London dispersion is the only force of attraction between atoms and nonpolar molecules. So in general, their strength increases as the mass and number of electrons in the molecular increases. Ganito lang yan, guys. Kahit gaano pa ka-weak ang isang bonding, no? Kapag mas malaki, mas madami, no? Mas lumalakas yung bonding. Ganun siya. So the more na humahaba yung, say for example, sa CH3, methane yan, tama? Expand natin yan ha. Pag in-expand ko to, ganito to. Ay, sorry, CH4 pala yung methane. Okay? Compare natin yan sa C... Compare natin yan dito. Guys, present parehas dyan ang London dispersion, pero mas strong ang London dispersion dito kasi mas malaki siya. Okay, mas malawak yung sakop ng London dispersion na force. Kasi mas malaki siya. Mas malawak yung surface area niya compare kay CH4 lamang. Okay, so kahit gaano pa kahina si London dispersion as a bond, no, pag madami siya dun sa molecule na yon, mas malakas yung attraction niya. So even though these forces are very weak, ito nga sinabi ko, they contribute significantly to the attractive force between them, between large molecules because they act over large surface area. Yung surface area yung nagpapalaki. How about dipole-dipole interaction? So dipole-dipole interaction, the electrostatic attraction between positive and negative dipole. So consider butane and acetone compound of similar molecular weight. So say for example, butane and acetone. No? Kung mapapansin niyo yung dipole-dipole natin dito, pareha silang may dipole-dipole. Okay, kapag nag-combine. Kaya sandaan ninyo, sa isang fluid ng butane gas, ng butane, liquid butane, no? Hindi lang isang ganito yung makikita ninyo. Dikit-dikit yan na ganyan, no? Paulit-ulit yan, pero hindi magkakadikit, no? Kumbaga ito ay nasa isang molecule lamang yan. May isa pa ulit na molecule na similar dyan. So, maraming ganyan. Okay? At ano yung nagkoconnect sa mga molecule na yun para mag-form ng liquid? Guys, yung dipole-dipole, London dispersion, ma'am, pwede ba mag-exist yun? Dipole-dipole and London dispersion in one um, molecular structures na similar molecules? Oo naman. Ito, meron siyang dipole-dipole interaction, meron din yung London dispersion. Okay, pwede mag-exist yun. Okay? So, yung dipole-dipole interaction, no, similar siya halos kay London dispersion, no, na kapag mas malaki, syempre, mas malakas yung interaction. Pero meron ditong kakaiba sa dipole-dipole interaction. Okay? So, kung mapapansin ninyo, pag mas bulky, gaya nitong si acetone, paano kung sabi mas bulky? Mas dikit-dikit sila, mas mataas ang boiling point. Okay? Kapag mas malawak yung surface area, mas mababa yung boiling point. Nang bakit ganun? Guys, kasi kapag, say for example, kumbaga, mas mahirap tunawin mas mahirap tunawin yung isang bloke kumpara sa mga kristal na maliliit na nakadisperse. Ganun yung isipin ninyo kay dipole-dipole interaction. Okay? Mas mahirap tunawin yung isang bloke kaysa sa mga nakadisperse na mga crystals. No? So, ganun yung ating dipole-dipole. So, butane is a nonpolar molecule. The only interaction between butane molecules are London forces. Acetone is a polar molecule. Its molecules are held together with a liquid state by a dipole-dipole interaction and a London forces. Okay, so hydrogen bond, no? A non-covalent force of attraction between the partial positive charge on a hydrogen bonded to oxygen or nitrogen. Okay, oxygen or nitrogen. Gaya sa water, no? Nakadikit ang kanilang hydrogen bond sa oxygen at saka sa hydrogen. Okay? Usually, nag-exist siya ay kay hydrogen tsaka kay either oxygen or nitrogen. Ang ating hydrogen bond. And hydrogen bond is a non-covalent force of attraction between a partial positive charge on a hydrogen bond to an atom of high electronegativity. The strength of hydrogen bond is 2 to 10. No? So, sa kanilang tatlo, si hydrogen bond yung pinaka-strong, yung kapit. So, hydrogen bonding in a liquid water has an important effect on the physical properties of water. So, the relative high boiling point of water is due to the hydrogen bonding between water molecules. Okay, let's move on to liquid. So, liquid, as pressure increases in real gas, its molecule come closer and closer with the result that attraction between molecules become important. So, when distance decrease so that almost all molecules touch or almost touch, a gas condenses to a liquid. So, in liquid, there is a very little space between molecules. Consequently, liquids are difficult to compress. Okay? So, ang important na detail for liquid is the surface tension. So, the layer on the surface of liquid produced by an even intermolecular attraction at its surface. So, dahil pala sa intermolecular attraction, kaya yung mga karayom ninyo lumulutang sa ibabaw ng tubig. No? Dahil merong uneven intermolecular attraction at its surface. So, particularly sa water, yun yung ating hydrogen bond. So, molecules in the interior of the liquid have equal intermolecular force in all directions. Okay, so evaporation and condensation for liquid. Important property of liquid is that they evaporate, no? So in liquid, there is a distribution of kinetic energy among molecules. So some have high kinetic energy and move rapidly, others have low kinetic energy and move slowly. So however, it's moving more rapidly, has a higher kinetic energy, and moving upward, it can escape the liquid and enter the gaseous space above it. So yun yung evaporation. So if the container is open, this process continues until all molecules escape. Okay? Ito yun. So for solids naman, ang importante natin dito is our crystallization or yung solidification na tinatawag natin. So formation of solid from liquid naman yun. Okay? So, sa solid, meron tayong iba't ibang klase no, ng solid. We have ionic, molecular, polymeric, network, amorphous, and metallic. So, guys, makikimemorize na lang ako. Baka biglang lumabas sa exam. Lalo-lalo na yung mga example nila and yung characteristics nila. Okay? So, ito ay table 5-4. So, phases, any part of the system that looks uniform throughout. So, example, solid water, liquid water, gaseous water. So, phases change. Siyempre, from solid magiging gas or gas magiging liquid, liquid magiging solid, etc. Okay? So, yun lang yung ating short discussion for phases of matter or states of matter. Kindly please read your book. I know there's more to read sa book. I'll add additional learning. If uh, you still have time, please watch the video that I am about to send you. Thank you. Thank you.